In the realm of responsible machine learning, ensuring privacy and robustness are two critical pillars. These aspects are crucial in building AI systems that users can trust and rely on. So let's delve into what these concepts entail and how they can be effectively implemented in AI development. Privacy in machine learning focuses on protecting the data used to train and operate AI models. This means safeguarding sensitive information to prevent unauthorized access, misuse, or breaches. Data anonymization. Techniques like data anonymization and pseudonymization help protect individuals' identities by altering identifiable information. For example, in healthcare, patient data can be anonymized so that AI can analyze health trends without exposing personal health details. Differential privacy. This method ensures that the output of AI algorithms doesn't compromise the privacy of any individual data point. Companies like Apple and Google use differential privacy to collect usage statistics while protecting user data. Encryption. Encrypting data both at rest and in transit ensures that even if data is intercepted or accessed without authorization, it remains unreadable and secure. For instance, financial institutions encrypt transaction data to prevent breaches. Access controls. Implementing strict access controls ensures that only authorized individuals can access sensitive data. Role-based access control or RBA key systems are widely used to limit data access based on the user's role within the organization. The General Data Protection Regulation, or GDPR, in the European Union is a prime example of stringent privacy measures. Companies that handle EU citizens' data must comply with GDPR, which includes obtaining explicit consent, allowing data erasure requests, and ensuring data portability. Robustness in machine learning refers to the AI system's ability to operate reliably under various conditions, including unforeseen or adversarial scenarios. Adversarial training involves exposing AI models to adversarial examples, deliberately manipulated inputs designed to deceive the model during training. This practice helps AI systems become more resilient to such attacks. For example, autonomous vehicles are trained with adversarial scenarios to ensure they can handle unexpected situations on the road. Building redundancy and fail-safes into AI systems ensures that they can continue to function correctly, even when part of the system fails. In aviation, AI systems are designed with multiple backups to ensure safety and reliability. Continuous testing and validation of AI models against new data and scenarios help maintain their robustness. Companies like Tesla routinely update their self-driving AI with data from real-world driving conditions to enhance reliability. Ensuring that the data used for training is diverse and representative of all possible scenarios helps create robust AI models. This includes incorporating data from different demographic groups, environments, and conditions. Tesla's autopilot system is an example of robustness in AI. The system is continuously updated with data from millions of miles driven by Tesla vehicles, helping it handle various driving conditions and scenarios more effectively. Privacy and robustness are fundamental to responsible machine learning. By implementing strong privacy measures, organizations can protect user data and build trust. Simultaneously, ensuring robustness in AI systems allows them to function reliably and safely under diverse conditions. Together, these principles form the backbone of ethical and trustworthy AI development, fostering confidence and reliability in AI technologies.